Imagine me standing before you today representing the world's tallest skyscraper at 2,700 feet. America's tallest skyscraper would only come up to about right here on me. This relationship is better exemplified by this image, which photoshops the world's tallest skyscraper in the skyline of Manhattan. In today's world, skyscrapers are being built taller and taller, which raises the question, is there a limit to how tall skyscrapers can be built? I asked myself this question in my structural analysis course last semester. I thought for sure the answer would lie somewhere within the structural integrity of the building, but it doesn't at all. Instead, the major limitation on future skyscraper growth lies within current elevator technology. Throughout the course of this presentation, I will describe to you how the heights of the world's tallest buildings have changed over the last 100 years. I will then explain to you how elevators work, and finally, I will describe to you the impacts that elevators have on the efficient use of skyscrapers. Allow me to begin by describing to you how skyscrapers' heights have changed since the early 1900s. According to Empress, which is the #1 leading provider of building information worldwide, this chart here describes how the heights of the world's tallest buildings have changed along a timeline. Focusing in on the early 1900s to the early 2000s, skyscraper heights have changed by about 300 meters. Now, zooming in to 2004 to 2010, the same change occurred, about 300 meters difference. Although there's been steady growth over the last several decades, in recent years, skyscraper heights have been increasing rapidly. So now that we understand the direction that skyscraper heights is headed, allow me to explain the elevators which service these tall buildings. Elevators have been employing the same cables and pulleys mechanism since the early 1850s, when a man by the name of Elijah Otis invented what is known today as the modern elevator. You can see here that he employs a variety of cables and pulleys within his patent back in the early 1850s. Zoom into today, fast forward to today, and we have the current elevator, which, as Kate Asher describes in her book, The Heights Anatomy of a Skyscraper, which was published just a year after the construction period ended for the world's tallest building. There are a variety of pulleys and cables employed, which is powered by the main motor and hoists an elevator cab up and down to the desired floor. Now on the other end of the cable, there's a counterweight which kind of balances out the system of the elevator and the counterweight itself. As you can see, not much change has occurred within the actual mechanism, the lifting mechanism of the elevator. Now this leads into the problem of how it impacts skyscrapers and the efficient use of it. And the reason is because the cables themselves weigh so much that elevators are only able to reach the height of 600 meters in one direct run, or one direct elevator shaft. This is according to Skyscrapers, a book published in 2013 which describes not only current skyscrapers, but skyscrapers that plan to be constructed within the next decade. Now, as you can see here in red, that's the line of the elevator that goes up and it reaches its max height of 600 meters. You can see here on the two buildings on the right, they represent buildings that have already been built. And the ones here, the three on the left, represent buildings that are going to be built within the next decade. And you can see that they're actually going to be built taller than the world's tallest right here. Going back to my example as me serving as the world's tallest skyscraper, the elevator will only reach about right here on me, leaving this other area, this other floor area, unable to be reached by direct elevator, and also this area, all these floors, unable to be occupied with the use of direct elevators. Now these floors are able to be occupied, but it will be by the use of an express elevator. So basically how it works is you go up to as high as you can go, 600 meters, and transfer to these express elevators, which service the remaining floors. The best way to describe this to you is to relate it to the airline industry with layovers. Let's say you're flying from Pennsylvania to California and there's a layover in Chicago. You get from point A to point B in the end, but there's inefficient use of time and it's just a hassle in general. Same could be said about elevators that are in buildings beyond 600 meters. You want to get from the ground floor up to the 120th floor, you need to transfer on an elevator from a different elevator on floor 100, let's say. So ultimately this just creates inefficient use of the building, it's more costly, and it's just an aggravation to the building occupants. Which leads me into my conclusion. Throughout the course of this presentation, I've explained to you first how building heights have changed over the last 100 years. I then explained to you how elevators work And I finish by explaining the impacts elevators have on the efficient use of skyscrapers taller than 600 meters. As we look forward into the future and we see buildings being built that more so reflect not my height, but the height of, let's say, former NBA superstar Shaquille O'Neal. The elevator will only access about up to his waistline, leaving the other half of his body, or perhaps the other half of the skyscraper, unable to be serviced with a direct elevator. So if we want to see more and more taller and taller buildings being built around the world, we better hope there's a solution to the cables and pulley system within elevators. Thank you.